We're going to talk about slope, lines, how to find the equation of a line, the relationship between parallel, perpendicular, like all that stuff comes in today's session. So we start with a review of slope. The slope is how steep a line is. The variable used for slope is a lowercase m. It is the change in y over the change in x. If I have two coordinate points, it is y2 minus y1 over x2 minus x1. It is also known as rise over run. There are 4 types of slope. If your graph increases as you move from left to right, then it is positive slope. If it decreases as you move from left to right, it is negative slope. If you have a vertical line, then it is said to have no slope or undefined slope. And again, that would be vertical in equation form. That's an x equals a number and it has no y. So this could be something like x equals 2 would be the result of a vertical line. And slope equal to 0 would be a horizontal line, like a flat line with no incline. And that's a y equals a number with no x. So this would be like a y equals 2. So the bottom 2, I would say make sure you can, that's quick recall. I know vertical means it's an x equals, and it means that it has no slope or undefined slope. A horizontal means it has a slope that is 0, and it's a y equals equation, because there's no way to, when we start to plug things in, there's no way to plug in something that's undefined. You can't find those equations that way. If you think about, if you've ever been on a treadmill, right, the steeper your incline, the higher your incline would be the bigger the slope. When it's flat, it's at 0. If you could somehow get it to go straight up and down, I don't know how you would do that, but if you could get it straight up and down, there'd be no slope. There'd be nothing to grip onto, okay? You'd be falling flat on your face. And if there was a decline, like you're walking down a hill, that would have a negative slope. All right, 3 equations that we have to know. The slope intercept, which is the one I would say most people remember, okay? Y equals mx plus b. M is your slope. B is your y-intercept. And because intercepts go in coordinate point form, it would be 0b is how I would write the coordinate point. Then comes point slope. That is y minus y1 equals m times x minus x1. In that equation, the x1 and the y1 is what we replace, and then the m is your slope. And the last one is standard form. Standard form is ax plus by equals c. The x and y have to be on the same side. They have to all be whole numbers, so no fractions or decimals, and the x has to be positive. So there will be times in which the directions will say, find the equation of a line that blank has this kind of information. The default format is slope-intercept. So if it doesn't tell you, put it in standard form, or if it doesn't tell you, put it into point slope, then our default is always slope-intercept. You'll always put it in terms of y, or y in terms of x. Standardized tests sometimes do ask you, take this equation and put it in a standard form. And in that case, we would get rid of the fractions, we would get rid of the decimals, x and y on the same side, and x is positive. This could also be called general form. All right, example 1. We are finding the slope of this line. You're going to do it 2 different ways. One, use the graph line, and the other, get points and then use it. So if I want to count the rise and the run, does it matter where I start? No, I could pick either one to start, okay? So I could pick the one on the bottom and work my way up. That would be a rise of 2 and a run of -4, which is -1/2. Or I could go the other direction. I could start at the 2, go down 2 to 0, and that's a -2, and go right 4, and I still get -2/4, which is -1/2. So it doesn't matter which direction you count when you're finding slope. The second way it said to do it was using the coordinate points. So this would have been 0, 2. This would have been 4, 0. And I would do y2 minus y1 over x2 minus x1. Doesn't matter which ones are the 1s or the 2s as long as you're consistent. So if I start with this x1, y1, this x2, y2, I get 0 minus 2 over 4 minus 0. So all the ways should get you the same answers. Questions on that one? Okay, example 2 says find the slope and the y-intercept and then graph it. A is already in standard form, right? So, I mean, in slope-intercept form, I don't really have to do anything except for pull the information out of it. What's your slope? Negative 3. If I wanted to count the run, it's what? 1, because it would be negative 3 over 1. What's your y-intercept? 2. We put it in coordinate point form, so it's 0, 2. And then I go to my graph. I start at 0, 2, and I count my slope. Down 3 and to the right 1, or up 3 and to the left 1. You don't need both. 2 points make a line, but you could use either one. It's going to ask you to graph on tonight's homework. Remember, I said don't get frustrated. If you can't figure it out, if you got fat fingers, if your iPad doesn't like where you're touching the screen, feel free to draw it on Notability. It has to be one place or the other. Either drawn on WebAssign with your line or drawn on Notability or on a piece of paper. I don't care how you do it, but as long as you draw it. There's 2 ways to do it. Tap the line, tap 2 points, it will connect them. Or there's a little coordinate point thing. You can actually just physically type in 2 coordinate points. So I could have typed in 0, 2, and then I could have typed in, counted it out, and typed in 1, negative 1, and it would also make that line for me. All right, now I'm going to go to B. What's one way to figure out the slope and the y-intercept here? Yeah, 1. Good, so you're going to solve for y. I'm going to subtract the 3x. 2y equals negative 3x plus 6, and then divide by 2. So this one's getting it into slope-intercept form. And then from here, I'd know m was negative 3 halves, and my y-intercept, 0, 3. The other way is if it's in standard form, there's a shortcut for slope. It is negative a over b. So if it's in standard form, I can do negative 3 over 2. That also gives you your slope. And then your y-intercept, you can actually just plug 0 in for x like we were doing last section. Plug 0 in for x, solve what's left, and you get 3 for your y-intercept. So there's different ways to do it. You don't have to do it. You get to choose which way you want to do it as long as you get one of those ways. All right, so now I'm going to graph it. I'm going to start at my y-intercept. This time is 0, 3. And my slope is negative 3 halves. So down 1, 2, 3 to the right 2. Or up 1, 2, 3 to the left 2. Questions on those? Feeling good today? Feeling smart today, hopefully? Yes? Okay. All right, now we're going to find the equations of the lines. So you'll get given all different types of information in these two. A is giving you the slope and then a point that it passes through, and B is giving you 2 points. So if I have the slope and the coordinate point, I tend to pick point slope. You don't have to. You could also do y equals mx plus b, solve for b, plug it back in. But if I'm given the slope and a point, I tend to use point slope. So y minus y1 equals m times x minus x1. And I get y minus a negative 2 becomes plus 2 equals negative 3/4 x minus 3. I'm going to distribute the negative 3/4. Y plus 2 equals negative 3/4 x plus 9/4. And then I'm going to subtract the 2. I get negative 3/4 x. Give it a like denominator, so I need it to be over 4. 2 becomes 8/4. And this becomes plus 1/4. You could have also done sloped intercept. So I could have also made this my x, this my y, that my m. So I could have done negative 2 equals negative 3/4 times x plus b. I would have to solve for b and then plug back in the m and the b. Hi. All right, last concept is parallel and perpendicular. So parallel lines have the same slope. The symbol for parallel is those two like sideways lines. And perpendicular lines have slopes that are opposite reciprocals of each other. Upside down, T. So if it's the parallel, we're going to keep the slopes the same. And if it's perpendicular, we're going to flip it and we're going to change its sign. Example 4 is just asking, are these lines parallel, perpendicular, or neither? So we're going to look at each set, figure out what the slopes are, and then compare them. If you look at A, what would you have to do first before you can pull out the slope?
Divide by 3.
Good. So I'd end up with 1/3 in front of the x. I don't even care about the 6 because I just want to know about the slopes. And I get 1/3 and 3. Those are obviously not the same. They are reciprocals, but are they opposite? Good. So this is a neither scenario. And in B, if I found the slope, 9 minus a negative 1 over 5 minus 0, I get 10/5 or 2 over 1. And then 1 minus 3 over 4 minus 0, and I get negative 2/4, which is negative 1/2. So what's true about these lines? They're perpendicular. Yep.
Would the first one be perpendicular if the 3 was in the
Yes. Yep. All right, the last question, and I will say that this is where people make the most amount of mistakes. It says, write the equation of a line given through point A, or given through the point that is A parallel and B perpendicular to the given line. This is 2 questions built into one. 1, the lines are parallel. 1, the lines are perpendicular. Then it gives you the line that it wants you to match the slope to or pull the slope out of, and then it gives you a point. So they are both going to use the slope from the first one. If it's parallel, you keep it. If it's perpendicular, we switch it to opposite reciprocal. And they're both going to use the point. So the shortcut, remember for standard form, is negative A over B for slope, which means this is negative 3/4. Now if A says parallel to that, what's the slope of A? If the line is parallel, what's true about the slopes? They're the same. So M is going to be negative 3/4. B is perpendicular. So what's going to be the slope of B? Positive 4/3. And then they will both use the coordinate point negative 2/3 and 7/8. I'm going to plug it into point slope. So I start with A. I get Y minus Y1 is 7/8 equals M negative 3/4. X minus a negative 2/3 becomes plus 2/3. So I get Y minus 7/8 equals, distribute here, negative 3/4 X. When I multiply by a negative 3/4, the 3's cancel. 2 goes into 4 twice, and I get negative 1/2. And then I'm going to add the 7/8 at the end. And I get y equals negative 3/4 x multiplied by 4, negative 4/8 plus 7/8 is 3/8. Now the mistake made here when people do this is they use the opposite reciprocal slope. Okay, so they use the right slope, but then they pull over this b, and that is not the case. They do not necessarily share a y-intercept. All you get from the first equation is its slope. You do it opposite reciprocal, and then you use the point that's given. So for b, I would go y minus 7/8 equals 4/3 x minus a negative 2/3, which becomes plus 2/3. And then I go through the whole process again. Distribute. Add the 7/8. And I get y equals 4/3 x. And this is where it gets yucky because I have to change both of these. 64 70-seconds plus 63 70-seconds. And I get 127/72. I would check to make sure that that can be reduced. It can't. But your numbers could get yucky. Don't get scared, okay? That's it.